Hello Discoverers, Princess Jennifer Vinson here. Let's talk about impulse and momentum. In chemistry, we learn about the conservation of matter. Here in physics, we learn about the conservation of energy. These concepts can be extended to formulate another law, and that is the law of conservation of momentum. Momentum is a term we may be familiar with, but once again, we must learn the rigorous definitions of these words. In linear momentum is defined as mass times velocity, which will be represented by letter P. Momentum is a vector quantity as it involves a velocity vector being multiplied by the scalar value of this object's mass. This means momentum will be expressed with SI units of kilogram meters per second. In this case, our everyday use of the word is fairly accurate, and we might say that as a ball rolls down a hill, it will gather momentum. This is true because its velocity will increase as the force of gravity accelerates towards the ground. The more momentum the ball gathers, the more difficult it will be to bring it to a stop. And an object in motion can therefore have a larger momentum by virtue of being more massive, like a huge boulder, or also by moving at high velocity, like a tiny hailstone or meteorite falling from the sky. If we considered a car in motion, it too will have a momentum equal to mass times velocity. And if you slam on the brakes to avoid the collision, the car will skid a certain distance because of force must be applied over some duration of time to bring a moving object to rest. The heavier the car and the faster it was moving, the greater this factor will be. A small force acting over a long time could do it, like if you take off your foot off the gas and let the friction from the road slowly stop the car, or a large force acting over a short time can do it, like firmly applying the brakes to the tires. The force that is applied multiplied by the duration of time that it is implied is called the impulse, which will be measured in Newton's second.
Hello, I'm Shamela David and I will discuss the relationship between the impulse and momentum. It is summarized in the impulse-momentum theorem. It states that the impulse F delta t is equal to the change in momentum, or delta p, which can also be expressed as mv final minus mv initial. So if you apply some force to push an object for some duration of time, that object will gain a proportional amount of momentum. If an object loses momentum, it must be imparting some force to something else over some time period, just as the work energy theorem describes conservation of mechanical energy. The impulse momentum theorem describes conservation of linear momentum. Another ramification of this theorem is that the force imparted on a moving object when it strikes some surface will be very large if the impact is instantaneous and much less if the impact involves some time duration.
Hello there, my name is Lauren Paular and I will give an example that applies the impulse momentum theory. If you fall off your roof onto the ground, it will hurt. But if you fall onto the trampoline, it won't be as bad because the change in momentum imparted in your body, instead of happening instantly, will be delivered over the entire duration of your contact with the trampoline surface as it stretches from the force of your fall. This is also why baseball players are thought to swing through the ball rather than stopping the swing upon impact. Because if contact maintained between the bat and the ball for as long as possible, the maximum possible force will be imparted up on the ball. In the case of an object striking another object, total momentum will be conserved through the collision, and the sum of the momenta of the two objects will be the same before and after the collision. The easiest example of this concept involves balls on the pool table. We'll often observe that one ball has the momentum while the other does not. And after the collision, the first ball has stopped and all of its momentum has been imparted on the other ball. This type of scenario illustrates conservation of momentum.